Hi all. So this is a quick video based on the concept saltatory conduction. So this question is usually asked as a 2-marker or physiological basis question. So we'll quickly see what this concept is about. So by definition, what do you mean by saltatory conduction? So saltatory conduction is a rapid transmission of action potentials in myelinated nerve fibers where the impulse jumps from one node of Ranvier to the next. So basically in this definition we are telling that it is a type of transmission which occurs in myelinated neurons where the action potential jumps from one node of Ranvier to the other. So why does this happen? So we'll just see about the concept, the mechanism of saltatory conduction. So suppose this is the axon which has got a myelin sheath, and we know that this intersegment between the myelin sheath, that is called the node of Ranvier. So initially this axon is in a resting membrane, resting. So we've got this, that is why we've got this negative potential inside the axon. Now suppose there is a stimulus at the axon hillock. So suppose the first node of Ranvier. What happens? Suppose there is a stimulus, there will be sudden opening of this voltage gated sodium channels which will cause influx of sodium. So what happens because of the influx of sodium? There will be depolarization at this node of Ranvier which will produce an action potential, right? Now what happens? Now this influx of sodium channels will produce a local current which will be transmitted electrotonically to the next node of Ranvier. So why doesn't this decrease as it moves to the next node? Because this is surrounded by the myelin sheath, so there is no leakage of ions. So whatever influx is here, it will be transmitted electrotonically in full effect to the next node of Ranvier. So what happens here? This part is now cross the threshold, so there will be opening up of sodium channels. Again there will be influx of the sodium ions causing a depolarization there, and this will continue to the next node and so on. So basically here the action potential is generated only at this node of Ranvier. That is why we say the action potential jumps from one node to other. Actually it is not jumping here. The mechanism is an electrotronic conduction of the local currents, but because the action potential is produced only at the node of Ranvier, we call it as the impulse is jumping. So saltatory conduction is occurring. So now I hope this concept is clear. So the mechanism is the myelin sheath will act like an insulator. There will be no ion leakage. The action potential occurs only at the node of Ranvier, which has got high density of voltage gated sodium channels. The depolarization of one node creates a local current that quickly depolarizes to the next node. So this is the mechanism of saltatory conduction. What is the importance of saltatory conditions? What are the important features of saltatory condition? The importance is this is much faster when compared to the conduction in unmyelinated fibers. That means here in large myelinated fibers the speed can be up to 120 meters per second. So that is why saltatory conduction is very important. Not only that, it is very energy efficient because only fewer sodium pumps are needed to bring it back to the resting membrane potential, because the action potential is being generated only at the node of Ranvier. So these are the important features of saltatory conduction. So we'll just stop it with by giving a clinical relevance. So suppose a myelin is lost. For example, there are conditions called multiple sclerosis in which there will be loss of myelin. So in this case there will be severe slowing or blocks in conduction which can cause paralysis of various groups of muscles. Okay, so I hope now this concept of saltatory conduction is clear. Thank you.